Okay, it's recording now.
Yeah. That's perfect. That's just leave it. That's good. And it's on?
Yes, it's on now.
Okay. Okay. This is the escapement and pallet fork templates which have been made from.
Moment at least. I'll shift it a bit. Center.
Yeah, I think it's okay. Okay. So this is the escapement and pallet fork templates which we have made by NC wire cut from very thin sheet metal. The escapement wheel is 6¼ inches in diameter, and the center distance between the pallet fork shaft and the escapement shaft is 6 1/16 inch. The escapement has 30 teeth and rotates clockwise according to the auxiliary view shown in Rimbaud's engraving of the Lucknow clock of 1885, which we will take a photograph and send separately. Now, to start with, this the entry pallet is on the left and the exit pallet is on the right, and the inside and outside faces of the pallets have been curved as circular arcs with the center of the pallet fork lever shaft at the center to have deadbeat action. But you will notice the tooth on the left hand side resting on the outer face of the entry pallet, and the teeth of the escapement are leaning forward by 5 degrees. So only the tip of the tooth is resting on the outside face of the entry pallet. The pendulum is on the rightmost position, so the entry pallet has entered the escapement almost to its full depth. Now, as the pendulum swings to the left, I am moving it to the left with my right hand. Up to this point, the tip of the tooth is sliding on the outer curved surface of the entry pallet, and the escapement is dead. It is not having any recoil forward or backwards. At this point, the entry pallet has released the tooth, and so the escapement will start rotating, and the tip of the tooth will slide across the angle face of the entry pallet. Now I am taking it to about quarter of the way across the angle face at this position. This is the position. Now I am rotating it a little more. It goes to about halfway across the angle face. Then I am moving it a little more. It is about a quarter of the way across, 3/4 of a way across the angle face. Now I move it a little more, and it goes at this point. It has slid across the angle face of the entry pallet. So this action of the tooth sliding across the angle face of the entry pallet is giving the pendulum impulse towards the left. At this point, the entry pallet and the tooth of the escapement are fully disengaged, and the escapement is free to rotate under power now. And you can see the right side pallet, the exit pallet, is close to the escapement teeth, and as the pendulum swings further, you see the tooth of the escapement is about 1/16 of an inch above the inside face of the exit pallet, and as the escapement is free to rotate, and as the escapement rotates clockwise, the pendulum continues to swing to the left, and the tip of the tooth on the right hand side is arrested by the inside face of the exit pallet at this point, and so the escapement stops rotating. And now as the pendulum continues to swing to the left, the tip of the tooth slides along the inside curved face of the entry pallet and until this position where the exit pallet has entered the gap in the escapement fully. And you can see once again only the tip of the tooth is resting on the inside curved face of the pallet. The rest of the tooth is relieved and clear. Now at this play point, the pendulum starts to swing to the right. So the exit pallet is now disengaging, and the tip of the tooth is sliding along the inside curved face of the exit pallet up till this point. At this point, the tooth has moved clear of the inside curved face, and now the escapement tooth is being released by the exit pallet. So the escapement is now free to rotate and give impulse to the pendulum to the right. Now I am showing the escapement rotating about quarter of the way across the angle face of the exit pallet. Now I am rotating it further to about halfway across the angle face, and now I am rotating a little further at about 3/4 of the way across the angle face of the exit pallet, and now all the way across the angle face. So at this point, the exit pallet is released the escapement fully, and the left hand side entry pallet is approaching the escapement to enter the gap between the teeth and again engage the teeth on the outside face of the entry pallet. Right? Now it is one point which is clear from this sort of simulation, that when the entry pallet is entering and withdrawing from the escapement, the exit pallet is not fouling with the escapement tooth, and similarly when the exit pallet is entering or withdrawing from the gap from the escapement the gap between the escapement teeth, there is no fouling with the entry pallet. So we have been able to take care of the fouling issue, but I am not sure whether we have been able to optimize the angle faces of the entry and exit pallets to make the impulse to the left and to the right equal, right? So this, I hope this video makes it clear the working of the design for the escapement and the pallet fork which we have made. Thank you.
Done? Stop.
Yeah.
Akhilesh, yes, here. Let's play back and see. 9 minutes.
9 minutes.
Yeah.
Will this be able to go in?
We'll see. We'll see the file size, otherwise we'll do something. Okay.